The resultant geometry from a topology optimization is a facet body, and historically this would have meant a level of reverse engineering to create a model that was suitable for downstream applications such as drawings or manufacturing. But with Convergent Modelling Technology in NX means you can now work directly on the facet body without the need for time-consuming reverse engineering. So we convert the optimized facet body into a convergent body, and as you can see, when we section it, there is thickness to the body that was generated by the optimization. So let's look at adding some detail to our convergent body. Apart from the Boolean operations and trims and offsets that we can do, we're also able to directly work on the facet edges, and in this case we're going to create some chamfers and some blends by utilizing the Krait Transition command. The convergent body is still facet geometry, and all we need to do here is to select points around the edge of the facet body that we want to create the transition on. And when NX has enough information, it completes the command and generates the chamfer at the required size. We now change the transition type to a blend and then go through the same procedure to create a blend transition on this facet edge. The last bit of detailing we're going to do is to add some of the fixing holes, and to do this we're simply going to reference some geometry from our original design. Simply copy and pasting one of the faces into our new optimized design enables us to accurately position the fixing holes. We select the hole feature, and then we select the direction for the hole, and then we use the edges off that copied face to position the holes exactly where we need them, remembering that these parametric features are being added to facet geometry. So just to recap, you've seen how in NX we were able to take an optimized facet body, convert it to a convergent body, and then add detailed features such as transitions, blends and hole features directly to a facet body without the need for any time-consuming reverse engineering. And now our optimized design could be sent directly to a 3D printer for manufacturing.